Okay, this is question number 12. In a controlled experiment, the number of microbes n present in a culture t days after the start of the experiment were counted. N and t are expected to satisfy the relationship of the form n equals a t to the b, where a and b are constants. Part A. Show that this relationship can be expressed in the form log base 10 of n equals m log base 10 of t plus c, given m and c in terms of the constants a and or b. Okay, so we've got n equals a t to the power of b. We're going to take log base 10 of both sides, first of all. This is a bit of exponential to logarithmic form, if you will. Is log base 10 of a t to the b. I want to break this apart into its separate fractions, into its separate bits. So we've got log base 10 of a plus log base 10 of t to the b. Using the log law, I can bring the power down to the front. So plus b log 10 of t. Okay, therefore m will be the b, and the c will be the log base 10 of a. Okay, that's part A. Let's have a look at part B. Scroll back up here. Okay, and here's the graph. Lovely. Figure 3 shows the line of best fit for values of log base 10 of n plotted against values of log base 10 of t. Part B, use the information provided to estimate the number of microbes present in the culture 3 days after the start of the experiment. Now, we want 3 days. So, we want C. Let's get the pen up. C is the log base 10 of A. That's helpful to me. Now, it's going to be quite tight, isn't it? It's going to be very, very tight. It's like, I actually want to say it's like 3 days. That's really low. That's like 1.84, something like that. It's roughly 1.84. I'll go with it. No, the mark scheme does have like a little bit of leeway, if you will. So A will be 10 to the power of 1.84. Okay? The M, the gradient, is B, which is, now I'm going to have to read off these values. That higher one up there is about 4.6. Up there. Take away the 1.84 I've just found, and I divide that by that low one down there, which is 1.22 on the log base 10t axis. It's 1.22. And obviously that one's at the origin, so let's take 0. Calculator. Get 138 over 61. Okay? So n is equal to 10 to the power of 1.84 multiplied by t to the power of 138 over 61. I don't want to really convert that to a decimal because decimals are horrible. Okay? So we want it after 3 days. So we want n when t, capital T, is equal to 3. So, into the calculator, it's 830.594. So we can have a whole microbe, so I'll round that up to 831.23SF. Okay, that is part B. Okay, part C. Explain why the information provided could not reliably be used to estimate the day when the number of microbes in the culture first exceeds 1 million. Well, for part C, we'll have log base 10 of t being equal to 1.2. So t is 1 with 15.84, and so roughly. Okay, which is the furthest data point. So if we did, t would be equal to that 1 million divided by the 10 to the 1.84 to the power of that 61 over 138 on the calculator. And I'm getting about 69 roughly. Hopefully you get the same as me. So, what we could say is this will be an extrapolation of data, and so would not be reliable. That will do the job. Okay, 2 marks for that one. Okay, part D. With reference to the model, interpret the value of the constant A. Okay. A is the population of microbes is it the end of the day? It'd be the end of the day, wouldn't it? That's the end of day 1 or the first day would do. Okay. And that is how you can get all the 9 marks here on question number 12.